So a boatman can row with a speed of 10 kilometers per hour in flowing water. If the river flows with a velocity at 5 kilometers per hour, in which direction should the boatman row in order to reach a point on the other bank directly opposite to the point from where he started in the shortest possible time? Then if the width of the river is 1 kilometer, find the time taken to cross the river. So this is what I gave you. Okay, so let's do some sketches to represent whatever we have. Ekuya, Akusia Duma rather. Akusia,
Yes, please.
how are you?
Please, I'm fine.
Okay, so if this is the river, the boatman, this is the width of the river. And the width is equal to 1 kilometer. Assuming he starts riding the boat from this point. Okay. When we look at the shortest possible distance, it must be this. In the opposite, he's going to the opposite side of the bank. So it must be from, if he's starting from a point A, it must be to this point. This is the opposite. Because, and this is the shortest possible distance. When he goes this way, it's longer. So to beat the time, he's supposed to go this way. However, then he can also turn to this direction and row the boat. Because if he turns to this direction, he will end up getting to a point away from where he has to. Then he can also go straight. Because if he does go straight, he will also end up, he will not be able to catch oppositely to the point where he started. And so practically, the obvious direction to bring him here will be here. So he has to row the boat in this direction. So the boat has to be paddled in this direction. And as he does so, it can be here. But what is that angle of row? Which angle must he directly direct or position the boat to bring him here? And that is what we are looking at. Now the question, we are told that the river flows, if the river flows with the velocity of this, so we are assuming the river flows in this direction. Of course, when you draw, depending on how you want to answer, the river can also go this way. So, and this is the direction of the boat. Though the angle we don't know. If the river flows with a velocity of 5 meters per second, in which direction should the boatman row in order to reach a point on the other bank directly opposite to the point from where he started? Okay, directly opposite. So from here to this point. So this is velocity of the boat, even though we do not know how the precise angle to direct it. But all that we know is that this velocity was given to us for 10 kilometers per hour. So 10 km per hour. And this is VB. We are assuming the river flows in this direction. So this vector also represents the velocity of the river, V of the river. All that we intend doing is that we want to represent the velocities so that it creates a certain triangle, and so we can be able to solve our question. Once we've done this, this is the direction of the boat, or the man. This is the direction of the river because it flows here. Then this, if you look at the other directions, this side must be the resultant velocity V of this and this. This velocity, the resultant velocity certainly is perpendicular to this. So we conclude that to find V, to find this, V of the boat squared minus V of the river squared would give us the resultant V. Therefore, V is equal to 10 squared minus 5 squared, giving us 100 plus 5 times 100 minus 5. This is 105 times 95. When you multiply and then you take the square root of it, you find V. Please do the multiplication, take the square root for me. What is V? Yaba, Ekuya Doma, Ekuya, Akusua. I'm waiting for you.
It's 99.9.
99.9.
Eight.
Hold on. Let's check our figures. Okay, the boat rose. Okay. This is 10. In flowing water, if the river, blah, blah, blah. Okay. So with the available information, we can easily find the angle theta. So we don't know this. So if we have the hypotenuse, if we have this and this, we can easily. Agosia.
Mr. Dear,
Hello.
please can we resolve it because you see the VR where it's pointing to and then where V is pointing to. Like, can that be the resultant?
No, VR is the velocity of the river because I said let's consider the river flowing from left to right. And so this becomes the direction of the river. That's why we indicated that here. Are you okay? So the river flows
Yes, please.
like this, from left to right.
Yes.
Then the angle tan, we can take tangent of this because we have this, we have that. We can also use sine. We can also use cosine, provided we have all that it takes. If we use sine theta, we have VR on VB. VR is what is VR? Okay, VR is 5. So 5 on 10. So this is 0.5. Therefore, theta is equal to the sine inverse of 0.5. And that is, what's the sine inverse of 0.5? That's 30. That's 30 degrees. Good. So
Yes,
theta is 30 degrees. Okay. Theta is 30 degrees. Now, if the width of the river is 1 kilometer, find the time taken to cross the river. So we are looking for this resultant, the time taken for this resultant crossing this width. The width of the river is 1 kilometer. So if the width of the river is 1 kilometer and the velocity along this side, the resultant velocity, we got 99.9. Then we can use V is equal to distance over time concept. Therefore, T is equal to S on V to find that. So we have 1 kilometer divided by 99.9 kilometer per. Therefore, divide 1 by that for us. 1 divided by
the answer is 0.0100.
so 0.0100.
Yes, please.
Okay. I'm also looking at, we have this hypotenuse. We are looking for this. So once we have this, okay, we use that to determine the, so 1 divided by 99.9, we have 0.0100. 0.0100 R, which we can convert to minutes. Okay. So that is how to determine the question. Okay, Lauren.
This is equal to the weight of the.
Hey, who is playing? Let me mute. I'm coming. Let me mute all. Let's continue our discussion on movements. Quick one. So, in our last meeting, we saw that the moment of a force is the turning effect produced by a force. And moment can be determined by the product of the force and the perpendicular distance about the point of rotation or the fulcrum or the pivot. Moment is a vector quantity, meaning it has magnitude and it has direction. SI unit of moment is Newton meter. Okay. The concept of moment depends on, or the moment, the magnitude of the moment or the turning effect, which we also refer to as the torque. The turning effect of a force is the moment of a force or the torque. Depends on the force, magnitude of the force, and then also depends on the perpendicular distance, meaning the greater the force, the greater will be the moment, and the greater the perpendicular distance or the moment arm. Please, if there's a bar and then force, the pivot is here. This is the force. The perpendicular distance is from here to this point. This is the force, and this is the perpendicular distance, which we also call as the moment arm. Moment arm. Okay. The larger the force, the larger will be the moment. The larger the moment arm, the larger will be the moment. And this is the reason why you can balance or have a situation where a very fat person sits at one point. Then a very slim person also sits at the other end. Or small. Now what happens is that because this person is so fat, this person is so slim in mass, quickly there will be turning effects in the direction of the fat person. You see the slim person turned shot up like this. Now, the slim person can also decide to vary, okay, to balance the fat person. Why don't I vary my sitting position? So if the person was sitting somewhere here and we had this situation, he can be coming back. Whilst he comes back, because movement depends on the product of the force and the perpendicular distance, you realize that the turning effect will be changing. A certain position can ensure that, the whole movement balances. And a typical application of what I'm telling you is this. Let's see, I have this arrangement. We have a mass of 100 kilogram sitting by a perpendicular distance of maybe 1 meter. Then we have a mass of 10 kilogram sitting beside an unknown mass or distance, perpendicular distance. We can figure the perpendicular distance away from the point or the pivot where the whole system will be balanced. We can figure that out. So, meaning that if we want to balance this arrangement, then one of the principles of moment says that the sum of the turning effect about one point must be balanced by the turning effect at the other end. And this would give us a clockwise turning effect, clockwise moment or torque. This would also give us anti-clockwise because it will turn in this direction. When the force exerts this way, it will turn in this direction. So this is clockwise, this is anti-clockwise. Please, are we okay? Do you understand that aspect? So anti-clockwise movement, clockwise movement. For stability or balance, this moment must be equal to this moment. So we say that the sum of clockwise moments must be equal to the sum of anti-clockwise moments. These are directions. This represents this, and this one represents that, as I've done here. Okay. So if I want to determine where this mass, 10 kilogram mass, must sit to balance 100 kilogram mass sitting at 1 meter from the pivot, then 10 kilogram by unknown distance must be equal to 100 kilogram by 1 meter. Therefore, x, the unknown distance x will be equal to 100 divided by 10, which is equal to 10 meter. What we imply here is that to balance this heavy person, then this smaller mass must sit 10 meters away from the pivot and we'll have a state of equilibrium. Please, are we okay? Are we fine with this?
Yes, please.
So no matter how heavy a load is or a mass is, if the bar is longer enough, we can still vary the position of the smaller mass or force and we'll have a state of balance or equilibrium. Okay. Now in calculation of moments, yes, moment or torque is equal to the force times perpendicular distance. Okay. Because for stability, we equate sum of clockwise movement to the sum of anti-clockwise movement. Usually there's, if I have the masses or what is, yes, on the bar as masses, there's no need of me converting it to forces before, because look, this is 10 kilogram. If I convert to force, meaning 10 times 10 meter per second squared, must be equated to the other moment, anti-clockwise moment. And this will be 100 times 10 times the perpendicular distance. This is unknown. This perpendicular distance is 1. Meaning that at the end of it, 10 meter per second squared, 10 meter per would cancel out, and it brings me back to masses. So if I'm equating, there is no need of me multiplying by gravity to convert them to forces. I can do the same thing and the value will be the same. Please, are we okay?
Yes, please.
Good. So let's come to the principles of moment. Oh, today's attendance, I'm not happy with it. Please let me draw the attention on the platform, okay? How can only 10 of us be here? Let me draw the attention of all.
Clockwise.
So this will give me a clockwise moment. Then the 5 Newton, will it give clockwise or anti-clockwise moment?
Anti-clockwise.
So this will also give us anti-clockwise or counterclockwise. This will give us same. So we have 2 anti-clockwise moments against 1 clockwise moment. So sum of anti-clockwise moments. This is my letter representation or diagram, because if I use this, then I mean that the turning is like this. And this is anti-clockwise. So when you see the diagram, this is what it means. So the sum of anti-clockwise moment, which is the force, first one, 5 times 4.5. The distance of F, the 5 from the pivot O, is 4.5. Plus 3 times, what is the perpendicular distance from the point O to the force 3 Newton? Yes. What's the perpendicular distance? Inshira, what's the perpendicular distance? Inshira?
5.
Again?
5 meters.
5.
Good. That is 5. So 2 plus 3. So this is 5. So totaling 4.5 times 5. Calculate for me. 4.5 times 5.
22.5.
So this is 22.5 plus 15. So this is equal to 37.5. Now let's look at the clockwise movement. The clockwise movement, we have 6. We have 6 times 2, giving us, did I say 12? 6 times 2, giving us 12. 12, this is please Newton meter. This is Newton meter. Therefore, the rule says that sum of clockwise movement must be equal to the sum of anti-clockwise movement for equilibrium. Now, because when you check, they are not the same, one is greater than the other, then the rule or the principle will not hold, but there will be a net. The net or the resultant moment will give us the turning effect in one direction. Hence, the net, the resultant moment or torque, moment, turning effect, I mean, will be equal to the greater one, which is the sum of the anti-clockwise moments minus the sum of the clockwise movement. So the net or the sum will result to 37.5 minus 12.0 Newton, which will give us, which will be equal to what?
25.
5.
25 Newton meter. What it means is that if these are people sitting on the bar, then the bar turns to, it turns to the anti-clockwise direction. There wouldn't be a balance, but the resultant will turn to the anti-clockwise direction. Please, are we okay? Are we okay?
Yeah.
I'm going to give you another one to try. Then we come to when we have two pivots. Let me use the other side of the board. We have this bar. We have a rigid bar. It is pivoted. Okay, let me use a 9 point. It is pivoted here. We have a force of 4, okay, F1, 300 Newton, acting at a distance of 4 meters from the pivot. This is 4 meters from the pivot. Then we have another force. This force, F2, is 600. 600 Newton, acting at an angle of 60 degrees to the bar. the distance from the pivot to where the force acts. This is 3 meters. The force is F2, and F2 is this, 600 Newton. Then we have another force which acts this is F3. Okay, let me bring F3 here. The magnitude of F3, 500. It acts at an angle of 60 degrees. Sorry, 50 to the bar. Find the sum of the forces, or find the net torque. Find the net torque. Okay, I haven't provided. This is acting from the pivot to where this acts. We are told the distance is 5 meters. Find the net torque. The net turning effect around the bar. Yes, 3 minutes. Make me proud. Make me proud within 3 minutes. Time. So I'm to find the net torque. Where will the turning effect move to? Okay. Now, I have some forces that are not acting exactly perpendicular. Some forces that are not acting exactly perpendicular. So what I have to do is that I must resolve so that I can get the component of the force which is directly perpendicular. Yes, F3 is 500. So let's resolve to get a component of this, which will be exactly 500 perpendicular to it. So when we resolve this component, if this is 50, this component of it is this. So this once this is 50, the remaining angle can be 40, or I can maintain the 50 as I was given, then do this. This will be the vertical component of it. Equal vectors. This side is the same as this side. So this will be F3 sine 50. And so this side is the same as F3 sine of 50. And this component, vertical component, will be perpendicular to this. Or another way to do the same thing. You see, this is the length from the pivot, L. Assuming I'm not doing this, L, which is 5 though. When I extend the line of action of the force from where it came from, okay, if I should extend it, it's here. Okay, I think this will be the obvious the direction. We only would have to resolve the force rather. So F sine 50. Okay. I don't need the horizontal component because I need a component which is perpendicular to the distance. If there's a pivot, and I have this F3 sine 50. Then let's pick the other one. The other one, when the 600 Newton, when we resolve, assuming let's extend it. When we resolve it, a component which will be perpendicular to the bar would be this component. And this side would also be 600 or F2 sine 60. So we have this component acting on the bar, F2 sine 60. As for and F2 sine 60 is at a distance of 4 meters away. So this is 4. As for F1, it is already, oh, sorry, that is 3. This component is 3. Okay, it's 3 meters. As for F1, we have it there. It is acting here. And that is 4 from it. So we identify Rich, you are giving us feedback. So let me mute Rich, else she will get Rich. Good. So let's identify the clockwise moment. F, this component turns in this direction around the pivot. F2, even though the force is acting here, but the component, the effective component which does the turning will be the vertical component, and it will act in this direction. F1 gives us a clockwise movement. So we have one clockwise movement as against 2 anti-clockwise movements. Okay, so sum of clockwise movements, even though we have one, which defeats the adjective sum there, but let's use it. This will give us F1 times 4. And F1 is 300. 300 by 4. Then the sum of anti-clockwise movement. And that will be F3. F3 is 500 sine 50 by the perpendicular distance, which is 5, plus plus the F2, which is 600 by 60, times 3. Plus, are we okay here?
Yes, please.
Okay, so let's find the values. What is 500 times sine 50 times 5? Do the calculation for me.
383.
I'm coming in.
Celia.
Hello, I'm coming. I want to confirm too.
It's
What?
383.
383. Oh, I also got I got 90,915. Check.
Yes, please.
Yes. So please, whenever you are punching your calculator and there's angle, check if the angular measurement is in degree or radian or gradient. That DRG, which is displayed on your calculator, very, very important. Okay, so when you are coming to press any angle, sine, cos, blah, 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 check if it's on D. If it's not on D, it can affect your calculation. So this is 19,915.1 plus, oh, I omitted a sign, sine 60. And sine 60 is root 3 on 2. Okay, or 0.838816. So sine 60, let somebody work it out too. Sine 60 times 1800, and that is 1,558.8. Correct? Correct?
Yes, please. Yeah.
Hello?
Please, why are you adding F3 and F2?
You see, F3 is giving me anti-clockwise movement. F2 is also, this component is going up, isn't it? The
Yes,
component
please.
which is perpendicular to this will be here. And it's the same as what is here. This will, by direction, this is also turning, this will also turn through anti-clockwise. This will also give me anti-clockwise moment. So I'm telling the sum of anti-clockwise moment. This plus this. Akosi, are you okay?
No, I thought F2 was moving in a clockwise direction.
I think because I have a lot of, this is F2. Please, it's good to probe, yes. Sometimes this confuses, so it's good she's asking. Akosia, this is the original F2 acting at an angle of 60 degrees on the bar. And I gave F2 to be, I think, 600. Akosia, are you okay?
Yes, please.
So this is the original. No. The turning effect is caused by the component of it, which is perpendicular to the bar. Hence, the need for us to get a component of this, which will be perpendicular to the bar. And we saw that that component will be F2 sine 60. Are you okay?
Yes, please.
What is the direction? It is going up. The arrow indicates the direction. Once it's going up, then it means this will turn and give us anti-clockwise movement because it's going up. Hence this arrow. This is also giving us anti-clockwise. So we have to sum up the anti-clockwise movement, which is this F2 sine 60 times the perpendicular distance plus F3 sine 50 times the perpendicular distance. Akosi, are you okay?
Yes, please.
To the whole house, are we okay?
Yes.
Okay, so let's add whatever we've had. This plus 1915. So the sum of anti-clockwise moments, we have 3475.8 Newton meter. Agosia, Adua Asante, are you there?
Yes, please.
Okay. So let's then determine the single clockwise movement. So the clockwise movement around is equal to this one. As for this one, there is no, it is directly perpendicular. F1 times the perpendicular distance, which is 4. Therefore, we have 300 times 4. Yaba. Yaba. So we have 1,200.
Yes,
Okay. We have 1,200 Newton meter. Therefore, the net or the resultant turning effect net moment or torque around will be the sum of the anti-clockwise moment minus this. So 3,475.8 minus 1,200, which is equal to 2273.
5.8.
Yes. And what will be the direction of what's the direction of the resultant moment or torque? What's the direction? It will be to the anti-clockwise. So simple. Not difficult at all. Now, Ama, are you there? Ama, Yakuma. Oh, she's gone.
Yes, please.
Sometimes we can have two pivots, two supports. Are you done writing?
Yes,
Are we,
please.
to all of you?
Yes, please.
Okay. Sometimes we can have two pivots. And how do we go about such a situation? Example, I have a bar. Let me divide my board. I have this bar. It is pivoted. We have two pivots, supports. This is support X. Then we have another support B. This is Y. Now, each of the supports or pivots would produce a reaction. The reason is that when the weight rests on the pivots, there should be a force perpendicular to it to sort of press the two so that it will not easily be displaced from the pivot. So each pivot will produce that normal reaction which presses the bar onto it. So let's call this reaction X, and let's call the reactional force produced by this as reactional Y. Now this one is at a distance of 1 meter from the pivot, or from the end. So from the end to where this support or pivot is, we have 1 meter. This 1, 2 is 2 meters away from the end. So from the end of the bar to where the pivot is, this distance is 2 meters. Now, we have the weight of the bar. This is 2, and the weight is 2 meters away from this one. So from here to this point, we have the weight of the bar giving us 15 grams, and this is 2 meters away from X. From this point, the weight to this point, we have 1 meter away, as given in the question. We have 2 masses at the ends. This is 10 gram mass at the end of this bar. We have another mass, 8 gram mass at the other end. The question is that we have to find the reactions at X and Y. So find the reactional forces, find the reaction at X and Y. So quick one, 2 minutes to engage your brain. Think through it. Let's see what you can produce before I come in. Finished. Okay, so let's look at it. Now, here what you do is that we have 2 supports. You always take the turning effect around 1. You assume 1 is gone, or you close one of them and take the turning effect around the other one. So you assume this is not there. Any one you begin with. So I'm assuming only X is there, but you overlooking this doesn't go away with the reaction there. For equilibrium's sake, you maintain it. You maintain the reaction produced by that pivot you've covered. The pivot you've assumed isn't present, but it doesn't go away with the reaction. Take note. So you look at the turning effect produced by each one. You have this mass. Okay, so here we are considering turning effect or moment around X. You look at the turning effect produced by each one of them. This will turn anti-clockwise. What about F? The 15 gram. Will it turn clockwise or anti-clockwise? Yes, the 15 gram mass.
Clockwise.
This will go clockwise like this. What about the 10 gram mass? Will it be clockwise or anti-clockwise?
Clockwise. Clockwise.
So this will give us clockwise movement. Then the Ry. Will it give us clockwise or anti-clockwise?
Anti-clockwise.
So this turns is going up, so it will turn this way. Anti-clockwise. What about Rx? Would Rx give us clockwise or anti-clockwise movement?
Clockwise.
Come again.
Clockwise.
Rx will not give us any turning effect. The reason is that turning effect or moment of a force is given by the force times the perpendicular distance. In the case of this, the force is Rx. But class, what is the perpendicular distance from this pivot? Is 0. And when the perpendicular distance is 0, when you multiply the torque or turning effect is 0. So if there's a force at a point where the rotation, where there is that axis where we take our axis of rotation, because there's no perpendicular distance, the turning effect is 0. So Charlotte, that is what you have to observe. When there's no perpendicular distance, the turning effect is 0. So this is as if it is not there. All right. So let's take our turning effect. This one will be 8 clockwise moments. So this is clockwise. So summation of clockwise moments is equal to 15 by, 15 by what? 15 by, oh, help me, quick one. Lizzie, Chrysler, Akia Adoma, Adwa Sante, Ishira Yaba, Millicent, I wish Lauren, Lynn, 15 by what?
2.
So 15 by 2 plus 10 by
2.
10 by
5.
5. Perpendicular distance from the pivot. And we are taking turning effect here. So times 5. 2, this like that. So 5. giving us 30 plus 50. We have 80.
Mr. Dia,
Hello,
please can I ask a question?
go ahead.
Please, are we finding the moment?
We are, yes, the turning effect produced.
So please, why you see this one is in grams, so
Yes,
like it's not in Newton. So why
yes.
didn't you multiply by 50?
Oh, you can do that, but it's not so necessary. At the end,
Okay.
when you quit, it will cancel. Okay. So the turning effect produced by this is this. So we can call this gram centimeter. The unit will be in gram centimeter, but because we never converted the masses,
Yes.
gram centimeter, if you like. Sorry, gram meter. Then let's look at the sum of the anti-clockwise movement. This is giving us anti-clockwise. This is also producing anti-clockwise. So Ry times what? Ry times
3.
3 plus 8 times
1.
Hey, Adwa,
Yes.
the sound at your ambience is unbearable. Okay, so sum of clockwise movement equals sum of anti-clockwise movement. So equate. And Akosia, this is where if we had multiplied to convert to forces, the value is the same because J will cancel out. Okay. So 80 is equal to Ry. This is 3Ry plus 8, giving us 3Ry is equal to 80 minus 8. And this is 70 what? 2. Therefore, Ry is equal to 72 divided by 3. What is 72 divided by 3? Plus 72 divided by 3. Oh,
24.
So 24. This will be 24 grams. Don't forget, we haven't converted, so you can write Newton. But if you want this in Newton, quickly you can do it. Okay. Now, how do we find any
Mr. Dia,
question? Hello,
please, my network was a bit, I was facing some
misbehaving.
challenge.
Okay, so ask your question. Mhm.
From the second part of the equation, I don't get it, like Ry times 3 times, sorry, plus 8. I don't
We
know how you
we
derive for that.
we are looking at we found the sum of anti-clockwise movement. So here we are looking for the clockwise movement. Please, my symbol represent clockwise. So this is clockwise, this is anti-clockwise. So I here, oh, okay, I think I earlier found the clockwise movement, which is this. And now this is the anti-clockwise movement.
Yes, that's the
Ry,
one I'm talking.
this one,
No, the anti-clockwise.
I'm coming. This one, Ry, which turns this way, times the perpendicular distance. This is 3. So 3 times Ry plus the other anti-clockwise moment, which is 8 grams times 1. So 8 times 1 meter. Okay, are you
Thank
okay?
you.
So
Yes,
after
please.
getting that, I equated it to whatever I had. So 80 is equal to 3y plus. All right, then. So let's see how we can find the other one. Over here in school or in the books, the shortest way is this. They apply, or the books apply the second law of moment. Sum of upward forces or masses must be equal to the sum of downward forces. So Rx plus Ry, then they equate it to 8 plus 15 plus 10. 8 plus 15 plus 10. On February. So Rx, February, Rx plus Ry is equal to 18 plus 15, which is
23.
23. 33. Okay. What is 25? When you add it, that's it. Now, having had Ry to be 24, Ry 24, Rx therefore is equal to 33 minus 24. Then that's a 6 plus 3, 9. So 9 grams, which is true. But I will not encourage this for now, even though it may be correct. I will not encourage this. I'd rather use this rule as a check, a way of verifying whether your answers are correct or wrong. So what I'll encourage that you do is that bring the other pivot back, the y. Y is back with a bang. Then now assume that x is not there. Earlier, we assumed that this isn't there. We took it around x. So taking moment around y. So we are taking moment around y as well. This time, let's clear. So in your books, you have to draw and then draw another one. Okay. So we are assuming this is not there. So the moment is taken around this one. What will this produce? This will produce anti-clockwise. This will also produce anti-clockwise. What about this? This will produce clockwise. What about Rx? Rx will produce clockwise or anti-clockwise, class? Rx will it produce clockwise or anti-clockwise? Oh, my people are not talking. Oh, would X produce clockwise or anti-clockwise moment? Hey,
None.
none, babe. I mean X. We are the pivot is Y. So will this produce clockwise or anti-clockwise moment?
Uh, Clockwise.
Clockwise. Lizzie, are you there?
Yes, please.
Hey, Crystal, are you there? Lynn, Millicent. What about RY? Would RY produce clockwise or anti-clockwise? RY. Would this produce clockwise or anti-clockwise movement? Wait, who is Mr. Hackman?
Yeah, please. Why? Whoa.
Equia, what will it produce? Your
X
line is
produce clockwise,
breaking.
anti-clockwise.
I
Yeah.
mean RY. Will it produce clockwise or
I'm
anti-clockwise?
asking, why is it?
Why is what?
Why is it clockwise?
You have this back.
RX clockwise.
You are late. Look at this. Look at this. You have this thing. And the turning effect is around where my hand is. So when the force, assuming the mass or the force is here, when the force acts, will it turn this clockwise or anti-clockwise? Will it turn this clockwise or anti-clockwise? Ama, hey, Equia, this will give anti-clockwise because the force is acting up. This will turn, the force is acting down, so it will turn, my hand is the pivotal. So this will go down. This will also turn around Y down. And then for the 10, it will turn this way. So that's the reason why this is anti-clockwise. This is anti-clockwise. This is anti-clockwise. This is clockwise. Okay. This will also go clockwise. Charlotte, what turning effect would RY give us? Clockwise or anti-clockwise? RY. Yes.
But it will move like to the left downwards.
Yaba, will it be clockwise or anti-clockwise? RY. Yaba is not there. Ama.
Sir, please, I think it won't produce any movement.
The movement there will be zero. Charlotte, I answered the same question for you. That's why I posed the question to you. When the force or the mass is at the pivot, at the point of rotation, because the perpendicular distance is zero, the turning effect is zero. Equia. So this will produce no turning effect. So let's look for the sum of anti-clockwise moments. Here we have 8 gram times 8 times what? I won't do this all alone. Lizzie, 8 times what? 8 times
1.
No. 8 times
3.
we are taking the turning effect around Y. So 8 times
5.
4. This is 1, 2. This is another one. So 4 meters. Okay. Plus 15 times
1.
15 times 1. These are the only anti-clockwise movement we have around. So let's sum them up. This is 8 by 4. 8, 4.
32.
32 plus 15. Summing up to 47 gram meter. Let's look for the sum of the clockwise movement. the clockwise movement, we have 10 times, 10 times. Lauren, speak. 10 times. I won't answer it all alone. You will help. 10 times
2.
2. Then Rx times what? Rx times
3.
1.
Rx times
3.
3. 2 plus 1, 3. So this is giving us 20 plus 3 Rx. So for equilibrium, sum of clockwise movement must be equal to the sum of anti-clockwise movement. So we have 47 being equal to 20 plus 3 Rx, giving us Rx is equal to 47. 3 Rx is equal to 47 minus 20. This is 27, correct?
Yes, please.
Yes.
Therefore, Rx would be equal to 27 divided by 3, which is
9.
9. 9. So this is 9 gram meter. Now, having had Rx and Ry, I will use the second law to rather test whether my figures are correct. The second law is that the sum of upward movement forces must be equal to the sum of downward forces. So I know Rx plus Ry must be equal to 8 plus 15 plus 10. 8 plus 15 plus 10. So they must all sum up to 33 gram centimeter. Now let's look at gram meter, sorry. Gram meter. Let's look at whatever we had for Rx and then Ry to see if it will sum, it will give me this sum. Rx we had 9, Ry we had 24. So 24 plus 9 would give me 33. 24 plus 9 will surely give me this. And so this goes to confirm that yes, then whatever we had for Rx and Ry is correct. If you use this one, you wouldn't know whether you are correct or wrong. If I use that second law to get the other one, yes, I'll have figures all right. But if you don't understand it so well, you may not be sure whether your Rx values and your Ry values are correct. But if you take the moment around the other one and you check, then when you use the second principle, you can be able to test whether your values are correct. Please, do you understand what I'm saying?
Yes, please.
You see, in the books, after hello, in your attaque, in your Akiola.
The next was I couldn't hear what you were saying.
Priscilla, what I'm saying is that in your attaque and then in your Akiola, what they do is that when they get one, they assuming or let's consider the point where we have had Ry to be 24. In determining Rx, all that they do is that they use the second law of movement, which is sum of upward forces. So Rx what they often do is that after getting 1, Rx plus Ry is equal to the sum of downward forces 8 plus 15 plus 10, which gives them 33. Yes, it's true. So because they have Ry, they quickly substitute that in to get Rx. So 33 minus Rx value, which is 24, and they are good to go. It's true. This can be right. But if you do that, you may not know whether your values Ry and Rx is correct or wrong. The best way out is that you took the moment around X, okay, around X initially to get Ry. When you finish, bring this back, bring X back, okay, and then take the moment around the other pivot. Okay, take the moment around the other pivot, meaning you have to take the moment around the 2 pivot to get Rx and Ry. So that when you finish, you use the second rule as a check whether your answers are correct or wrong. Because the second rule is that the sum of upward forces or masses must equal the sum of downward forces. So if whatever you had is right, then when you sum Ry and Rx values you've obtained, when you sum them, it must be equal to 8 plus 5 plus 10. So the second rule goes to look like a check on the correctness of your answers. That's what I'm saying. Please, is that okay?
Yes, please.
All right. So I think we have 3 minutes to end. I will send you a question, please. Those of you who are fond of not submitting assignment, I wouldn't tolerate that at all. You know me. You know me, and my assignments haven't even started. I'm now going to start. Your parents are on the platform. If you don't do it, your name will not appear on the submission list and they will make you out. So please, let's put in some efforts and then work hard, okay? Myself, it's not easy to be given assignment and marking it, but it's a must. I have to do it, and so you must also do it. And so this is why I draw the curtains on today's meeting. Thanks for your time. Thanks for everything. Please, you haven't been making time to view the video. Go to the line and then the handle and then watch the video after every session. So I think next week will be another beautiful time. Until then, please take care of yourselves and then bye-bye.
Bye.
Your
Bye.
questions will follow you.